Before we get into rational expressions, we're just going to review some factoring. So this is factoring you would have learned in grade 10, but we'll just quickly go over it because you will have to know how to factor in order to simplify rational expressions. So when we are factoring, the three questions we generally ask, the first question is there a common factor? That's what we always check for first. Then we look at how many terms there are. The number of terms will direct us as to what to do next. So if there are two terms, it could be a difference of squares. If there are three terms, it's either a simple or a complex trinomial. And if there are more than three terms, then we're going to have to group. So we'll go over examples of each. And then at the very end, you always ask, am I finished factoring? Sometimes there is more than one type of factoring, and so it might be a multi-step question. Okay, so common factoring, you're just looking for common numbers and variables that you see in all terms. So in part A here, I'm looking for a common variable or number. The common variable would be a squared. So think of factoring as the opposite of expanding. So let's just write this down here for a second. So I see that both terms have two a's. So factoring is the opposite of expanding. So I could, let's write it down here. I could put my a squared below each term and see what is left over. So a squared is what is common. In the first term we had three a's. We factored out two, so we would have one left. In the second term we have the two left and the a's are taken out. There were two, we took out two, so we have none left. So factoring is like dividing, expanding is multiplying. So if I expanded this bracket, I would get this answer. Let's just erase this, we don't really need this here. So you don't have to write it like that, but sometimes it's helpful to see what's left over. So if I expand a squared times a, I get back to a third to the power 3. If I expand a squared times 2, I get 2a squared. So this is factoring, right? Factoring is like dividing each term by a common factor, and expanding is multiplying. So in the second example, I see a common 5. Both terms have an x. The first one has 2, the second term has 3. So 2 are common. And then we see y in both terms. They both have a minimum of 2, so we'll take 2 out. So that is the common factor. So in the first term, I've taken out the 5, I've taken out the 2 x's, I had 3 y's, I took out 2, I've got 1 left. 15 divided by 5 is 3. And we took out the 2 y's. We have an x left over because there were 3 and we took out 2. And then sometimes let's erase this so we have a bit of room here. Oh, maybe not. Okay, sometimes we have a bracket that is common. So you'll see both terms contain this bracket a plus b. So the common factor is a plus b. If I take it out of the first term, I would have the 7x left over. And if I took it out of the next group, I would have the 3y left over. The second type of factoring is a difference of squares. So once we check for a common, then we look at the number of terms. If there are two terms, it's more than likely a difference of squares. So remember that a difference of squares comes from multiplying two binomials that are the same but opposite in sign. So we'd have a times a times negative b, a times positive b, and b times b. And the middle terms will add to 0 because the binomials are the same but opposite in sign. So that's why you end up with two terms. There's actually 3, but the middle is 0. Right, so we don't have to write that. So we end up with two terms. So that's how we get a difference of squares. So they're easy to factor. We know that we'll take the square root of a, the square root of b. One will be minus, one will be plus. In the next question, we take the square root. So my checklist is, are there two terms? Yes, there is. Is it subtraction? Yes, it is. Are both terms squares? Could I square root both terms? Yes. So it has to check off those three factors. So the square root of 25 is 5, and then we have the x. The square root of 9y is 3, and the y. 1 is a plus, 1 is a minus. Make sure that you put it in the proper order. The 25 is at the beginning, so the 5 will go at the beginning of the bracket, and then the minus x plus x will go at the end. This is not the same as x minus 5, x plus 5. If I expand x minus 5x plus 5, I get x squared minus 25, which is not the same as 25 minus x squared because of the signs. In 25 minus x squared, the 25 is positive, the x squared is negative. In x squared minus 25, the 25 is negative and the x squared is positive. So it's not the same thing. Okay, so make sure that you don't have to put the variable at the front of the bracket. You can put it at the end of the bracket. In this question, I see a common a. So I'm going to take that out first. And also when I look at it, it's not a difference of squares because both terms are not squares. Once they take out the common factor a, then I have a difference of squares. So then that goes to the question, am I finished? So once I've taken out a common factor, can I still keep factoring? And then lastly, if the exponent, this is a difference of squares, it has two terms, it is subtraction. They are both squares. If the exponent is an even number, it's a square. So I just divide 6 by 2, that gives me 3. Square root of 64 is 8. And that is my final answer. The next type of factoring are simple trinomials. They will be 3 terms. A simple trinomial means the coefficient on the x squared is just 1. So think of a quadratic in standard form is ax squared plus bx plus c. So a simple trinomial means that the coefficient a is 1. So all we have to do is find two numbers that multiply to get the end and add to get the middle. So we could say, well, what multiplies to get 12? 1 and 12, 2 and 6, 3 and 4. Which combination adds to 7? The 3 and the 4. So I know it's going to be x plus 3, x plus 4. So why do we do multiply to get the end and add to get the middle? Because if I expanded this, x times x, x times 4, x times 3, and then 3 times 4. Oops, that's a 7. So where did the 7 come from? By adding the 4 and the 3. Where did the 12 come from? By multiplying 4 and 3. So that's why we can look at the two numbers that multiply to get the end and add to get the middle. You just have to be careful of signs. So this is similar, but the middle is minus 7. So 3 times 4 is 12, but this time they would both be negative because negative 3 plus negative 3 is negative 7, and negative 3 times negative 4 is positive 12. In this last example, again, the end is 12. This time it's a negative. So if I'm multiplying to get negative 12, the negative could go on the 1, or the 12 could go on the 2, or the 6. It could go on the 3, or the 4. So there's double the possibilities. I want the combination that adds to positive 1, which would be negative 3 and positive 4. So I know it's x minus 3 and x plus 4. So the only way you're going to get it wrong with simple trinomials is if you get a sign error. And you can always check by expanding. Okay, so it's pretty easy to check. Just expand it and make sure you got where you started. Complex trinomials are a little bit harder. You can do it trial and error. You can do it decomposition. So trial and error means you're just trying different combinations. The first one is fairly simple because I know 2x squared could only be 2x times x. And I know 3 could only be 3 and 1. I just have to figure out which one the 3 goes in and which one the 1 goes in. So 3 times 2 is 6. This gives me 6x, this gives me 1x. I want it to be positive 5, so the 6 would have to be positive and the 1 would have to be negative. So that's just doing trial and error, different composition or different combinations. We can also do decomposition. So decomposition is a step-by-step method that works every time. So what we do is we multiply the first number and the last number, and we get -6, and we write down the numbers that will multiply to get -6. I want the combination that gives me a positive 5 in the middle, which is this one. So we're going to decompose the middle. Instead of writing 5, we're going to write plus 6x minus 1x. That still adds to 5. So I haven't changed the equation. I've just replaced the 5 with a 6 and a -1. Then we are going to group the first two terms and the last two terms, and we're going to factor out of each bracket what is common. So in the first bracket, I see a common 2x. The second bracket, we're going to take out a -1. We don't want to start a bracket with a negative, so if it starts with a negative, take it out. That is the only thing that is common. And now what should happen is this bracket should be the same. So x plus 3 is common, and then 2x minus 1 goes in the other bracket. So let's look at this example. 6 times 14. Let's see what that is. So 6 times 14 is 84. So I'm going to multiply numbers to get 84. Till I find a combination that adds to the middle of 25. So we can just do 4 and 21. So 4 and 21 adds to 25, so I found my combination. I don't need to write them all. So we're going to replace 25x with 4x plus 21x, which adds to 25. So we've replaced the middle with two numbers that add to the same amount. Then we're going to group the first two. In the first bracket, there's a common 2x. In the second bracket, there's a common 7. And if this can be factored, this bracket should be the same. So that is one factor that is common, and then 2x plus 7 goes in the other bracket. It doesn't matter whether you put the 4x first or the 21x. I'll just show you. Order does not matter. So I could put the 21x first and the 4x second, and then group. So in the first bracket now a 3x is common, and in the second bracket a 2 is common. And so you can see that now the 2x plus 7 comes out as a common factor, and the 3x plus 2 is left over and goes in the other bracket. So you still end up with the same result. It's just that you pull out a different common factor. And then lastly, we have grouping. Grouping is more than 3 terms. So it's kind of like the middle step of decomposition. If I group, if I have more than 2 terms, I'm going to group the first 2 and the last 2 and look for a common factor. So y squared in the first bracket, 2 in the second bracket, and then I see a common binomial, y minus 1. And then the y squared plus 2 would go in the other bracket. And then in this grouping, in the first bracket, I see a common x squared. Second bracket, it starts with a negative, so I'm going to take out -1. X minus 8 is now common. Left over is x squared minus 1. Be careful, because x squared minus 1 can be factored as well. It is a difference of squares, so make sure that you always check your result to make sure that you can keep factoring or not. So that is a review of factoring. This is all the factoring you should have learned in grade 10. But if you are not as confident in your factoring, I would suggest that you do some practice. I will also mention that at the beginning of the unit, there is algebra skills. Actually, I think it's at the beginning of the course. And in the algebra skills, there will also be a factoring review.